So what I have here is a triangle, and I'm going to find the midsegment of this triangle. Remember that a midsegment is a segment that connects midpoint to midpoint of two sides of the triangle. In total, there are three midsegments of any triangle, but I'm just going to find one right now. So I'm going to find the midpoint of side HL. So that's using points H and L. So that would be -7 plus 5 over 2 comma 2 plus 4 over 2. That's HL, 2 plus 4 over 2. Okay. So what I have here is -2 over 2, which is -1, and 6 over 2, which is 3. So that's -1, 1, 2, 3. And look at that. That is right in the middle. Now I'm going to find the midpoint of side LK. So that's using points L and K. So that is 5 plus 3 over 2, comma 4 plus -4 over 2. So that's 8 over 2, which is 4. And that's 0 over 2, which is 0. So that's 1, 2, 3, 4, 0. Look at that, right in the middle. Using my straight edge, I'm going to connect the midpoints of those two sides together. And here I have one of the midsegments of this triangle. Now what I'm going to do is I'm going to find the length of midsegment MN using the distance formula. So I just found points M and N. So let me plug those into the distance formula. So I have 4 minus -1 squared plus 0 minus 3 squared. So that's 25 plus 9. And what that is radical 34. And now I'm going to find the length of HK, the side of the triangle that the midsegment's not touching, or the base of the triangle. So, and let me put down radical 34. Here we go. Okay, so let me plug in. So that is 3 minus -7 and -4 minus 2. So that is 10 squared, which is 100. And that is -6 squared, which is 36. So that is radical 136. Now I want to compare the lengths of the midsegment MN and the side of the triangle that it's not touching, HK. So I'm going to go on over to my calculator and I'm just going to divide. I'm going to do radical 136 and I'm going to divide that by radical 34. And when I divide the two, what I get when I do radical 136 over radical 34 is I get 2. So that tells me the midsegment is half the length of the side of the triangle that it's not touching. Or in other words, the base of the triangle is double the midsegment. Now let's talk about slopes. So if I find the slope of MN, I'm just going to use my coordinates really quick and plug into slope formula. So that is 0 minus 3 over 4 minus -1, -3 over 5. And if I plug in for HK into slope formula, that is -4 minus 2 over 3 minus -7, -6 over 10. And that simplifies to -3 over 5. So both the slope of the midsegment and the third side of the triangle are the same. And when we have two line segments or lines that have the same slopes, that means that they are parallel. So not only is the midsegment half the length of the third side of the triangle, but it's also parallel to it as well. So those are our two parts of our midsegment theorem for triangles. Okay, let's apply our knowledge of triangle midsegments to some questions. So we're told that triangle ABC is equilateral. That means that all the three sides of this triangle are equal. It also means all of the angles of the triangle are equal, and that means that they are equal to 60 degrees to make 180 degrees of the triangle. We're told that AB is equal to 8, so that means all of the other sides of the triangle are also 8. We're also told that DE is a midsegment of the triangle, so we know that it's half the length of the third side. So if the third side is 8, the midsegment is half of that, which is 4. I also know that it's parallel to the third side. I don't know if that's going to be important, but I'll mark it just in case it is. Now, the question asked us to find BC, which we already did. It was 8. Find AD. So if DE is the midsegment, then that means D and E are midpoints of the sides that they're on, and midpoints split sides of the triangle equally. So if this whole side is 8, then that means that each half split by the midpoint is 4. So AD is 4. Measure of angle B is 60 degrees. Since triangle ABC was equilateral, all three of its angles are 60 degrees. Measure of angle ADE. Well, we have parallel lines cut by a transversal. So this angle and this angle, top right, same positions when the parallel line meets the transversal. When the parallel lines meet the transversal. We call those corresponding angles. And remember that corresponding angles are congruent when parallel lines are cut by a transversal. So angle ADE is also 60 degrees. And finally, the length of DE, which we already found to be 4 because the midsegment is half the length of the third side of the triangle. In the next question, we are told that D is the midpoint of AB and E is the midpoint of BC. And I know that midpoints split line segments into congruent parts. That tells me that DE is the midsegment of the triangle because it's connecting the midpoints of two sides together. Not only is the midsegment parallel to the third side of the triangle, it's also half the length of the third side of the triangle. So if we know that AC is 3x minus 15 and DE is equal to 6, we need to set up an equation to find x. So I know that if I take half of the third side of the triangle, I will get the midsegment. Multiplying by 2, I have 3x minus 15 is equal to 12. Adding 15 to both sides, I have 3x is equal to 27. And dividing by 3, x is equal to 9. Moving on, let's check out these next examples over here, and feel free to pause the video to try them on your own. A is the midpoint of UV. B is the midpoint of UW. And C is the midpoint of VW. VW is 7x minus 3, and AB is 3x plus 1. Find VC. So if I can find VW, half of VW will give me VC, since C is the midpoint of VW. And I know that AB is a midsegment of the triangle. It connects the midpoints of two sides together. And the midsegment of a triangle is half the length of the third side. So I know that if I take half of the third side of the triangle, I will get the midsegment, which is 3x plus 1. I'm going to multiply the other side by 2, both sides by 2. Remember to distribute the 2 to each of the terms. Subtracting 6x from both sides and adding 3 to both sides, I have x is equal to 5. Now plugging in, 7 times 5 is 35, minus 3 is 32, and half of 32 is 16. So the length of VC is 16. Here we have quadrilateral ABCD, and we're told that AB is parallel to CD. And we're also told that E, H, and F are the midpoints of AD, AC, and BC, respectively. If AB is 24, CD is 18, and AH is 10, then what is FH? So this one actually has a lot of information that we don't need because in this triangle, HF does connect midpoints together, so it is a midsegment of this triangle. And we know that a midsegment is half the length of the third side of the triangle. So if the third side of the triangle is 24, then the midsegment has to be 12. So that one actually had some information that we really didn't need. The answer is 12. That's the length of the midsegment. Now here in this question, we have a trapezoid with a midsegment. So trapezoid midsegments are pretty similar to triangle midsegments. They are parallel. Oops. Oh no. They are parallel to each of the bases because remember there are two bases in a trapezoid, and they're also equal to the average of the bases. So the midsegment of a trapezoid is half the sum of the bases or the average of the bases. So if we wanted to find what x was, the midsegment, which is 2x plus 4, is equal to the average of the bases. So I'm going to add the bases together and divide them by 2. I'm going to multiply both sides by 2. Remember to distribute the 2. And I'm going to combine my like terms on the top of this fraction. So that's 5x plus 3. Subtract 4x from both sides. Subtract 3 from both sides. 5 is equal to x. So we found our x value. It is 5. That was the first part of the question. The second part of the question is asking for the perimeter. We already have the 12 and the 16. That's 17. 5 times 3 is 15 plus 2 is 17. And here we have 11. So if we add together the sides, I have 12 plus 17 plus 16 plus 11, and I got 56 for my perimeter. Okay, here we have an isosceles trapezoid with a midsegment. So first we need to find x. So x is in the angles. So remember in an isosceles trapezoid, the base angles are congruent. That might come in handy. Remember also, the midsegment is parallel to the bases of the trapezoid. Okay, these two angles over here are supplementary. So if this is 131, 180 minus 131 is 49 degrees. Now we have the information about the parallel lines. So I'm going to take these two parallel lines, cut by this transversal. And what I have here is top, left, top, left. So these two angles are in the same position when the parallel lines meet the transversal. So we call these corresponding angles. And corresponding angles are congruent when we have parallel lines cut by a transversal. So if this is 49 degrees, this one's also 49 degrees as well. And since we know in an isosceles trapezoid, the base angles are congruent to each other, I can set up the equation that says the bottom base angle, which is represented as 5x minus 1, is equal to 49, the other bottom base angle. So adding 1 to both sides, I have 5x is equal to 50. And then dividing both sides by 5, I have x is equal to 10. Now, to find my y value, my y is actually on the side of the triangle over here. So I know that we have a midsegment, and a midsegment connects midpoints together. So if this point is the midpoint of the side of the trapezoid, I know it splits the side equally in half. So I know that 5y minus 6 is equal to 24. So adding 6 to both sides, we have 5y is equal to 30. So we have y is equal to 6. Okay, let's construct the midsegment of a trapezoid. And constructing a midsegment of a trapezoid and a triangle is the same thing. We need to make the midpoints of the legs for the trapezoid. For the triangle, it would just be the midpoints of any two sides. So to find the midpoint, we're going to use the perpendicular bisector construction. So first, I'm going to start with this leg over here. So I'm going to put my point on one of the endpoints of the trapezoid. I'm going to open up more than halfway, about 3/4 of the way down, and I'm going to make an arc that goes, oops. Oh no, my arc is swinging out of control here. Let me try that again. It's very, very difficult to do constructions on the computer. So I'm going to make an arc that goes above, below, and without changing the distance, I'm going to go over to the other endpoint. And what I'm going to do is I'm going to make the same exact arc. And through those intersection points with my straight edge, I'm going to draw my perpendicular bisector. And where the perpendicular bisector hits the leg of the triangle, that is the midpoint of that leg. So what I'm going to do now is I'm going to do the same thing to the other leg to find the midpoint of that leg. So let me head on over here. I'm going to put my compass on an endpoint of that leg. Once again, I'm going to open up more than halfway down, about 3/4 of the way, arc above and below, without changing the distance. I'm going to go over to the other endpoint, and I'm going to make the same exact arc. Using my straight edge once again, I'm going to connect the two intersection points to form my perpendicular bisector. And where my perpendicular bisector hits the leg of the trapezoid is the midpoint of that leg. Now, all I'm going to do is take my straight edge and connect the midpoints of the legs together, and that purple segment is the midsegment of the trapezoid. So the first part of this question says to graph the midsegment of this trapezoid. So take a second and find the midpoint of the legs and connect them together to find the midsegment. Please pause the video as you do this. Okay, the next part of the question says to write the equation of the line containing the midsegment. So to write the equation of any line, you need two things. You need a point and you need a slope. We already have 2 points that are on the midsegment. You can choose whichever one you want to use because we have both of the endpoints. I'm going to use this one because it's nicer to work with than using a decimal. You need the slope of the midsegment, so please pause the video and take a second to find the slope of the midsegment. And the slope of the midsegment does work out to be 1/2. So now that I have a point and a slope, I can use point form to really easily write the equation of the midsegment. I'm going to plug in the y coordinate of my point for y1, my slope for m, and the x coordinate of my point for x1. And that's a really good equation of the midsegment. We're all done. If the question does specify the solve out for y to put into y equals mx plus b form, which is also called slope-intercept form, you should solve for y. So I'll do that now to show you how to do that. But it's definitely okay to leave your answer in point slope form if it is a short answer question. Better to avoid solving incorrectly and leave as is than to solve for y incorrectly and actually get a mathematical error and points taken off. So let me distribute. And let me add 3. So let me get the calculator for this one. I'm going to type in negative 1/2 plus 3, and that's 2.5. There we go. But it's really easy to make a mathematical error solving, so I would recommend just leaving in point slope form. Perfectly valid.